Power's off now.
Okay.
Okay? So locate the furnace fan switch and perform the following. Okay? So now, what is the resistance of the switch? Now I told you guys we need to remove one of the two wires or both wires. Okay? So what I'm going to do is I'm going to just take one wire off. Okay? That's good enough. It's out of the circuit. I broke the circuit. All right?
Okay. Oh, I
Now,
see what you mean.
what I'm going to do is set it for ohms of resistance. Okay? And then what I'm going to do is I'm going to take my meter and get my reading off of my fan switch. Okay? I don't have it hooked up, but this is what you're going to do. I'm just showing you step by step.
Yeah.
Okay? So then you're going to get your reading. Okay? Now, was the fan switch open or closed to your ohm meter? I'll let you guys determine that. Okay?
Okay.
Once you're done, I recommend you to put the wire back on. Once you put it on, slide it back in. Okay? Just snug. You don't have to crank the living hell out of it. Just snug it. You're done. All right? Any questions so far?
No. Well, that was
Yes, it says ohms right there. Ohms is the omega sign, which is the horseshoe. Right there. Okay? All right, next page. Now it says remove the furnace fan relay and perform the following. Okay, check it out, guys. Oh, there's the fan relay. It says remove it, so unplug it. All right? Let's go up to the curve here. We can all see it. Okay. Now, examine the schematic on the relay. Determine the numbers for the normally closed contacts. List them here. Okay? Remember how I told you how to look at that?
Yeah. One
Right?
and two. One
What's
and two.
normally closed?
1 and 2.
And?
4 and 5.
Okay, excellent. Now it says determine the normally open contacts. What are they?
4 and 6. No, I mean 1 and 3.
1 and 3
4
and
and 6.
That's fine, yeah. 4 and 6 and 1 and 3 is fine. Perfect. Excellent. Now it says, with the ohm meter, determine the continuity of the normally open contacts of the fan relay. So what you're going to do is you're going to set this for ohms of resistance.
Yes.
Okay? I'm not going to plug it in because you'll see the answer. Now, before you do anything, guys, I want to show you something. I do got to plug it in to show you something. All right? This is a 105 thing. I'm getting you guys used to it now. If you take 105, you need to zero out your meter. What I mean by zeroing out the meter, when you check for ohms of resistance, you need to see how far off your meter is. Because that way you get a true, accurate reading.
Then from that we take like a 0.
Yes.
Okay.
Yes. Yeah. You guys are remembering. Excellent. But I want to go over it again. Very good, Andrew. All right, now check it out. What you're going to do is you're going to zero out the meter by putting the two probes together.
Yeah.
This meter is off by 0.3 ohms of resistance.
So that's when you subtract it when you get
For the
final answer.
total.
Yes. Very good, guys. Excellent. Okay. Anything over 0.5 ohms of resistance,
There's something wrong?
yeah, it's actually considered part of the load. You shouldn't have that much resistance. If you have that high of a resistance, maybe your leads are bad, maybe they're dirty, take some sandcloth and clean them up. Anything under 0.4 is good in my book. Okay? Just remember to subtract it like he said. Okay? So we said these are off by 0.3 ohms of resistance. Okay? All right, now, I'm going to take those out because I'm not going to show you what you're going to get. All right, examine the schematic for the relay. We already did that.
Yeah.
There we go. With your ohm meter, determine the continuity of the normally closed contacts. So what you're going to do is, okay, bring that a little closer there. All right, 1 and 2 are normally closed. So
Yes.
what we're going to do is we're going to put our meter on there, okay? If we read 0.3 ohms of resistance on our meter, what are we actually reading?
0.
0.
0. Very good, guys. Excellent. Okay? All right, now, so I want you to write that down. The next is, what determined the continuity, or ohm meter, determine the continuity of the normally open contacts. So then you're going to go from your 1 to your 3. Remember what I told you guys in class. 1 is common to 2 and common to 3. Okay? Then you're going to get your ohm reading there. 1 is common to 2 and 3. 4 is common to 5 and 6. Okay? All right, good. See, this stuff that I'm showing you guys, we normally don't teach that in 103, but you guys are actually picking that stuff up already.
Do we have to consider both this side and this side?
Yes.
separate.
So we're doing 4 and
set.
Yes, exactly. Like I said, this here is the dividing line.
Oh, okay.
This is the dividing line. 1, 2, 3, 4, 5, 6. These two here do not have numbers.
Uh-huh.
These two are your coil wires. So if you look, you have a thin piece of copper wire soldered on this side and this side. This copper wire goes down here, through here, spins around this iron core about thousands of times, comes out through the other side, up through here. So,
So
it's one,
it's like a current, right? So
exactly, it goes
and then
all the
come
way through. Exactly.
So in here, for testing the normally contacts.
What
so
number?
C?
Step 2.
Step 2,
C.
C, okay.
Okay, so we will just take the normally contact for this side and
Yes.
this side.
Yes.
Both
Okay.
sides?
Yep.
Okay.
Yep.
Okay.
Yeah.
Same also with this the open.
Yes, exactly. Okay. And then it says here, with the ohm meter, determine the continuity of the coil of the fan
So
relay.
this one.
Okay.
So these two.
Yes, exactly. Those two there. And if you don't remember what it is, like I said, guys, you can easily cheat and look.
Yeah.
You can just see the thin copper wire soldered to it. That's your coil. Okay. I'll show you. This is how to ohm out the coil for C or E.
E.
Step 2, letter E. All right. Zero it out. What's it off by? 0.3? So
Yep.
check it out, guys. So it's around 18.4
18.4
minus 0.3, so 18.1.
18.1.
Okay? All right, now, that's what the resistance of the fan coil relay is, or the coil of the relay. Okay? Any other questions so far? All right, good. Now, with the ohm meter, measure the continuity of the high temperature limit switch. Okay? So now let's go back.
Those extra two on the end with the fan relay coil.
Yeah.
So using
That's
this
E.
meter,
Okay.
we cannot follow this now.
It says here, when testing resistance, start. Oh, very good.
Yes.
Yes, I brought that up to the other students. All right, let's go back up here. I apologize. Yeah, we talked about that. I kind of jumped around. When testing resistance, start at the highest scale and work your way down to avoid a false infinity when measuring high resistance, such as a relay coil. Okay, that doesn't really pertain to us here. Okay. This here, back in the day, I mentioned this, and in the last group they actually remembered me talking about this.
The analog meter.
Yes, on the analog meter, very good. On the analog meter, they were not auto-ranging, okay? Today's world, we have the auto-ranging meter. You can just put it on volts. It doesn't care if it's 24 volts or 480 volts. It's going to auto-range, and you'll be fine. And it'll determine how many volts of power, how many volts are there present at the circuit. Back in the day, with the analog meter, they gave you multiple ranges of volts, amps, ohms of resistance, okay? So, for example, volts is the easiest, okay? Back in the day, you would have to set your dial for 480, 120, or 24, or whatever, even 25,000 volts, because they had meters that could handle stuff like that.
Wow.
With these, you just set it for volts and you're done, because it's auto-ranging. So what that means here is when testing resistance, start at the highest scale. If this is, even if this is 24 volts, which it is,
Yeah.
and if we had an analog meter, okay, we would start at 480 volts.
Oh, okay.
Okay, that's starting at the highest scale. And then we would look, and we would get like a really weird reading. It wouldn't really read right, okay?
Yeah.
The decimal point would be way off, and the dial wouldn't be working properly, okay? So then what you do is you slowly back it down to 120 and check. And then down to 24, and then you will see it on the scale itself
Yeah.
that you're reading proper. What'll happen is that they had a needle that goes like this, and the needle would just either would barely move or would
go
bury
crazy.
itself out. Yeah. Actually, it would just really barely move. Okay? So then you got to lower the scale. And then the meter would would actually move up a little bit more, so on and so forth. And then when you finally hit the right scale, then you would see it.
Okay.
But these here, you just turn them on and you're spoiled.
Yeah.
It's there. Okay?
Oh, so that doesn't really pertain to us.
Exactly. And that's what I said before I started explaining. Yeah, so you're right. Okay? So back in the day, that's how it used to be. Okay? And the reason for that is, okay, guys, is because if you, say like you had your meter set for 24 volts, and you go to check and there's 480, you're gonna boom, you're gonna blow up your meter.
Yeah.
And maybe injure yourself.
Exactly. That's even worse. But then again, if you got an expensive meter from back in the day, you know, Simpsons, those were the shit they had. If you had a Simpsons, you're a top-notch technician. Okay.
Did you ever have one?
I actually have one. It's at work, but I don't use it anymore because I use this. Well, I got a Fluke, but still.
Yeah.
I got 2 or 3 meters, but still, yeah. And, you know, top notch. That was an expensive meter. Like, ooh, you're big time when you had that stuff. Now it's all changed. Okay. So that's what that means there. It doesn't really pertain to you, but it's something to remember. Because if you ever go to a job and you're going to say, okay, here, that's what that means. That's what the don't mean. So it doesn't really pertain to us because we have auto ranging meters. Okay. All right. So thank you for that. All right. Now we already determined the resistance of the fan coil on the relay. Okay. With the ohm meter, measure the continuity of the high temperature limit switch. Okay. Now, if we're going to be measuring continuity, we need to have the power off.
Yeah.
Okay. So let's go back over here. Put this down here so we can read step by step. Okay. Our power is off. I'm going to plug this back in just to get it out of my way and I don't lose it. Okay, it's set for what now? Oh, high limit. Now, keep in mind, guys, when you're going to check a control, you need to take it out of the circuit by removing one or both of the wires.
Can I say why?
Because you're taking it out of the circuit. Because if you were to check this with both wires on,
I can measure the
Other devices.
you're going to
Other
measure
devices.
everything else in it. Yes.
Yeah.
So you're going to measure the resistance of the wire. You're going to measure resistance of maybe whatever it's tied into.
okay.
A whole entire control. But if you just want to check just the limit switch only,
Yeah.
you need to take one of the 2 wires off. My batteries are going dead.
Yeah.
You need to take one of the 2 wires off, and then you're going to check for ohms of resistance, and then you're going to write it down. Okay? That's standard practice for everything. Okay? So if you're checking control, that's even worse. Those things. All right.
Okay.
I should see if Art's got some batteries. That's my personal flash that I brought from work. Okay? Okay. Now, it's going to ask you, is the high temperature limit switch open and closed? I'll let you make that call. Okay? The limit switch is adjusted to open at what? What did I tell you guys? Or what did you tell me?
Between 900,
900.
no, 190.
190 and
205.
205. Excellent. Very good. Proud of you guys. Last group took a little longer. All right. Now, I'm going to put this wire back on because I already got that information. It doesn't tell me that, but I'm going to put it on anyways. Okay, now, it says here, the high temperature limit switch, is it connected in series with the following loads, transformer or gas valve? I'm going to tell you, I'm going to be honest with you guys right now. I'm going to give you guys this one. You can circle any one of those.
How come?
Okay? I'm glad you asked. You're the first one to ask. Okay? Because when we go to wire furnaces, you're going to understand that question. You can wire the high limit in the transformer of the gas valve.
Yeah.
This furnace could be wired either way, and you guys are going to do that later. Okay? So I'm not going to go out of my way to see if it's wired in there. So you can circle anyone you want. But when we go to do wiring of the furnaces, this is where you're going to understand what this means. So you can circle anyone. I don't care.
Okay.
All right?
But so far right now we know like is to the gas bulb, right?
Yeah, I don't know. I don't know if I think the limit is tied into. Oh wait, I can't tell by looking at the gas valve. The limit is tied into the transformer. It's not tied into the gas valve.
Okay.
So if it goes off on high limit, it's going to kill the 24 volts of the or the 120 volts to the transformer. Is what it says right now.
High limit, okay. It's
Okay?
120.
I can tell by looking how it's wired on the outside. Okay? This one here is wired that way. I wired this furnace last summer.
Okay.
Okay, now, with your ohm meter, measure the continuity of the gas valve operating coil. Power is still off, guys. Keep that in mind. So what you're going to do is, remember, take one of the 2 wires off. Alright? And then what you're going to do is you're going to actually test the coil on the actual gas valve. Okay? And you should see some type of resistance. If you don't see resistance on it, you got a bad gas valve.
Okay.
Alright? But we know you're going to see something. And when you're done, put the wire back on.
Doesn't matter which one, right?
No, I don't care. You can take this one off or this one. Doesn't
That
matter.
doesn't have a polarity.
No, no, it doesn't.
Oh, okay.
Okay, next. We're on step,
Next page.
yeah, next page. All right, now, let's turn on the gas supply. I already did that from the last group. We're gonna skip that. We're gonna go down to voltage readings. Okay, now, it says take the voltage reading for the following locations and components while the unit is on. Set the multimeter to voltage. Okay, volts, VAC. Turn the power on to the unit. Oh, don't drop it, rip it now. All right, check it out, guys. Turn the power on, stand back, we're gonna light the furnace. It's gonna roll out and burn us. Okay, now, it says here, measure the voltage at the terminals R and C of the transformer. Okay. I'm gonna go to R and C. All right. Here's my R. Here's my C. I'm gonna be measuring my voltage. Okay. I'm gonna write that down. Next is measure the R to W. Here's my R. Here's my W. Okay.
Those are written right there, right?
Yes, it is. Yes. Okay. Remember what I said, guys. The R is red in color.
Yeah.
If you look at this, this is a yellow wire. Because what we did is we took the red wire, wired it into a fusible link in case you guys short something out. It's gonna blow this fuse here, and actually, so it goes from yellow turns into a red, or goes from red turns into a yellow. Okay, so if you're trying to find the red wire, you don't see it. That's because it's tied into the fusible link. Okay.
Got it.
All right, now measure the voltage across the high temperature limit switch. Now, I want you to go up here, go to the limit. Okay, and check your limit. And I want you to check the voltage at the limit switch. Okay, keep in mind, guys, if you're going to be checking voltages, okay, you've got to be precise. You got to only touch the contacts. If you get lazy and sloppy like this, like what I'm doing, you can actually touch this to metal, and it's going to spark an arc and make a nice shock, and you're going to jump back because it's going to scare the hell out of you. If you look at the fan one right here, it's got a little bit of a char mark on it. Somebody actually shorted that out by touching that to this here. Okay? If it happens, try not to let it happen.
Yeah.
Okay? You're not going to get killed or anything, but it's going to scare the shit out of you.
Okay.
I've seen it happen. Okay? Okay. Now, measure the voltage across the high limit switch. Okay, we already did that. Now it says before the blower motor comes on. Well, the blower motor is on. So, if the blower motor comes on, this is what you have to do. Turn it off. Let it cycle down. When it cycles down, okay, what's going to happen is you have to restart it again. Not a big deal. So let's wait a little bit. So this is going to actually start cooling off. You guys might be working on this furnace, or we might actually have you work on the one with wheels.
Training.
Checking all the control.
It says for the transformer, we're taking it. It just slides out, right? Like you're not. It said it was.
You mean the relay?
You mean this one?
This here?
You just take it out.
Yeah, that's where we're at now.
Okay.
Yeah, that's where we're at now. So here, right here, before the blower motor comes on, okay? So before the blower motor comes on, you want to actually take the reading, okay? Then after the blower motor comes on, measure the voltage across the fan switch, okay? So let's start from the very beginning so we're not confused. Before the blower motor comes on, okay, so let's call for heat again. Okay, blower motor's not on yet, so let's hurry up and get our reading, okay? So we have it set for volts. We go to our fan motor. Which one was our fan? The blue or the red? Okay, so we're gonna measure here, get our reading, write it down. Then it says here, after the blower comes on, measure the voltage across the fan switch again. Okay? So let's wait for the blower motor to come on.
It's more like if we go by step, we'll get the hang of it.
It's written here, word for word.
Yeah.
Yeah. I mean, there's really no room for error here. Come on. cheated a little. Okay. Give it a little bit of boost there. All right, now after the fan comes on, you're gonna do it again. All right, you're gonna check your power. All right, check for voltage. Okay. After that, it says while the furnace is still operating, remove the furnace fan relay. The blower motor will stop. So check it out, guys. Okay, it stopped. Measure the voltage across the gas coil. Okay, we're still in voltage. We're going to go over here and measure the voltage. Okay, write it down. Then it says measure the voltage across the high temperature limit switch. So then we're going to go up here, measure the voltage. Okay, write it down. Okay. And is it open or is it closed? That's another thing too, guys. Pay attention to that. You need to tell me, is the switch open or closed? Okay? Any questions so far? All right, now, next is turn off the electrical power to the furnace. It's the only time I allow you to do that. Replace the furnace fan relay. Plug it back in. Okay? It only goes in one way. Okay? Now it says turn the power back on. Okay, and it says the blower should start, and it did. With the amp clamp on the amp probe, measure the amp draw of the motor. List the amp draw here. Okay, check it out, guys. These here are the wires for the blower motor. Okay, this is your neutral. This is your low speed. This is your high speed. Okay, I recommend you to, make it easy on yourself. You can take the amp draw off of the white wire. If you want to write that down, that's fine, okay? Because now the white wire is actually common to the red or the black, okay? And it's in the circuit. So what you're going to do is you're going to set your meter for amps, okay? Wait for Andrew here. Taking notes. All right, amps. You can see the picture of the amp clamp right there, okay? So what we're going to do is we're going to get our amp reading. Not two wires, just one wire, all right? So it's around 4.2 amps, okay? Let me show you. We should be on low speed because we're on auto. It's about 4.1. It isn't much at all, okay? 4.2. Black is the high speed. We're not reading much at all because we're not using the high speed. So there's less confusion by using the white wire, okay? Just to let you know, all right? You don't have to hold it like I'm doing, but I like to have the wire close to the meter as possible. This is fine too. See how much it's off? It's not much. Nothing
So
really.
it's better to have it.
Yeah, it's not really nothing to write home about, but there's a difference.
Yeah, there's
Okay? All right. Okay, guys. Let's see. Next. We're almost done. Turn off the electrical power. Well, what that means is lower the thermostat. Okay?